Why is it important in geometry? So there are different types of transformation, but isometry is the type of change that preserves the size and shape. It preserves the size and shape. That's why in the second bullet, it says it preserves the length, so that's the size. And it also preserves the angle, so that means it maintains the shape. Okay. We encountered the term pre-image earlier for the original picture, and then the image is the new picture after transformation. So since you're preserving the size and the shape, they will be congruent to each other. You don't have to copy the images, but it's just like some visual representations. When you see yourself in the mirror, your actual right becomes the image's left, correct? So that's what you call a flip or reflection. We looked at the example for a slide or translation, which is the band members moving in all directions by the same amount of distance. Now later on, we're going to take a look at turns where you're rotating the images in different directions. But even if you flip them around, reflect them over different lines, the shapes and size would still be the same. So that's what we call an isometric transformation. Isometry. In SAT, I saw a question before when I was proctoring. Which of the following transformations is isometric? So you got to figure out which preserves the size and shape of the object. Okay, so now we're going to do some hands-on activity. I will, let me see if I missed out any slide. Okay, now let's define what a translation is in geometry. I have here 3 images. A simple, movement of a pencil from one place to another could be considered a slide or a translation. When you move a square on the plane without changing its size, that's another example of translation. But one thing I want you to focus on is this one. Look at those apostrophes on the letters. What could those mean? Yes?
It means that they're the image or that they've been altered.
Good. So the original image are the original letters A, B, C, and D. This image was altered, moved, or transformed, and now the new location is indicated by the A prime, B prime, C prime, D prime. So when you see a picture like that, you don't have to ask Miss, which one is the original, which one is the new. So the new one is always the one with the primes. Okay. So technical definition, all right? Every point of the pre-image or original must move the same distance in the same direction. But I think the best analogy we could come up with for that is, the different formations. So when one member moves, the others follow the same direction. Unless, of course, they're trying to showcase a different formation. Okay, I think at this point we're going to go to decimals. Let me just double check on the next slide if I'm right. Oopsie. Okay, yeah, we're gonna do decimals. So let's go ahead and open that. I'm not sure if I saved the link in your Schoology. I will try to look. If not, I can just add that up. Okay. It's not there yet. Could you please log in using Google to your decimals account? And you will see 4.1 translations. Period 5. There you go. All right, you will see something like this. And feel free to play around with it. Just make sure you're answering the questions correctly, okay? All right, Sebastian is in it already. Okay, I think there's 3 possible answers here. So if you pick only 2, you're missing out on 1. You go to student.desmos.com and that's where you can access it. Student.desmos.com, and then just log in with Google if you previously logged into that before. If not, let me know and I can give you the code. Okay, so which ones do you think are right? A. C. One more. B. Very good. Although B looks like it's moving diagonally, right? But if you take a look at it again in the next slide, you'll see that they match. So click on next, and then now try to move that into. Oh, it's hard to do it on the screen. Okay, so there you go. So try to move that. That would match. There you go. And then if you move it diagonally and go to B, they should also match right there. And of course, it was more obvious when we moved upward. That should also be matching with figure C. All right. Why doesn't the original match with figure D?
Because it's rotated.
Rotated. Very good. Rotated. Good job. Okay. Let's move on to the third one. In order to move the original to match shape A, you can move it 3 units to the right. Whatever number you type will move the image left or right. So for example, if you type in 3, it will move 3 to the right. Okay, submit your work. But this will not save all your answers. So you can revise the first number, and then automatically the last answer will be the one that will be saved. Okay, how do you go to the purple one? Yes, Kobe. Negative. Okay, so let's go negative. How much? 4. Negative. How do I show negative here? Negative and then 4. All right. Oh no, I messed up. How do I delete that? Okay. Gotta do it again. I messed up. Negative. This keyboard is confusing. Okay, negative 4, Kobe said. Let's go. Nice. Good job, honey. All right. Okay, and try to match. What haven't we matched yet?
5.
So I put plus 5?
Yeah.
Okay, plus 5. How do I delete this one? Plus 5. Okay.
-5.
Oh, negative 5? Okay, 5. Submit. Okay, great. All right, so now we have combined horizontal translation with, this one is vertical translation. Okay, go ahead and type in some numbers in order to match them as well. Okay, make sure you are going over each slide. Okay, if you skip it, you won't get a point for that one. Yeah. So I'm going to count the slides that are done, and that's how I grade you. So you don't have to copy anything down to Schoology. I'll copy that myself. My last name. Okay. Well, Annie's not here today. Okay, let's just go by time entered because some of us are not here. Okay. Yeah, keep going. Don't wait for us. Nicola, just keep going.
Okay.
Yes. Okay. I'm going to help some of us in 5. Look at that. All right, make sure you match the original shape. So you can see some people here playing around with their shape. Some look like, okay, look at that. It looks like a boot or something. Yeah, reduce that letter L. Reduce that L by moving the dot. Somebody asked me, Miss, why does this corner doesn't have a movable thing? Well, it wants you to fix that one right there. Okay. I can see Sophia is done, Max is done. Okay, whose is this? I can't see the name over there. Jesse, all right. Okay, resize it. Jolene, Kobe, Nicola. All right, you're gonna click on those joints and reduce them. So like, for example, Angel, you move this one and move it down like that. Just so you will match the side of the original. That's the key. Match the sides. There you go, Angel. And just keep doing that. Okay? Got it? All right. Okay. I knew where to put the points because the translation is when. Okay, all right. I knew where to put these points by copying the size of the points of the original figure and to count the boxes. All right. The pre-image and image are congruent. That's why we count the boxes. It doesn't change the shape, so I just drag it to the shape of the original. Very good. Not dilating it. Good job. Okay. Oops, I lost what I was reading. All right. Okay, and keep writing your explanations. The shape doesn't change, so I just moved it. Okay, some of you are already in 6. Go ahead, write down your final thoughts. And let's do number 6. Okay, how come I don't see number 6 over here? All right, carefully describe how to translate or move the original shape to match the blue one exactly. I like how Sophia's writing it now. She's now writing it in symbols. You can do that too. Or use the vector. Or explain it in your own words. Good job. Those are the different ways that you guys can describe the movement or the transformation. Okay, Jesse, instead of a parentheses, use there's like a less than or greater than symbol. Yeah, so use the less than or greater than symbol. Very, very good, Brian. X plus 3. All right. Okay, move the shape. Move the shape 3 to the left. Is it 3 to the left or 3 to the right? 3 to the right. Okay. And then 2 up. All right. So Nicola, this is your original, so you're moving in this direction. So change your 3. Okay. That's good. So that's very important. You have to identify which one is the old and the new because the direction matters. Okay, let's keep moving. Number 7. In the table, enter the coordinates to translate the original shape. Let's show correctness so you guys can check your answer. Oh, you're not done yet, so I'll take that out for the meantime. So what basically are we doing to the x values? So you're given the original x and y. Okay, what are you going to do to the x if the shape is moved 5 to the right? Plus 5. Very good, Kobe. So x plus 5. What about the y? Y plus 3. Very good. All right, so that's all basically you're doing. You get the x number and then add 5. You get the y number and then you add 3. Okay, now let's show correctness on that one so you guys can see if your coordinates are right. It doesn't let me click on the screen. Okay, there. If you don't see a check mark, maybe one of the numbers is wrong. So fix that one. I don't know if I can show all the boxes. I'll try. Okay, if you see an X, some values are wrong, or maybe you're not done yet. Or maybe I could show the summary and it will also tell you whether it's right or wrong. Okay, there you go. All right, and keep moving. You have 3 slides to go if you're done with that table. If you finish your decimals, we're going to go to page 95 and 96 of the workbook. That's our last work for the day. Page 95, honey. You guys should be helping me next time. Fix this one. My back is killing me. I sound like Gollum now. Ay, okay.
What?
Right.
They'll stand there. They'll stand up there.
All right, most of you are done. Okay, again, if you see an X mark, please go back to that so you don't lose that point. That means there's something wrong in that particular slide.
I don't understand how to do number 7.
Number 7. Okay, let's do number 7.
What?
Okay, so for number 7, enter the coordinates to translate the original shape. So, okay. Here, for example, you're going to take the x value and then add 5 to it because it's going to the right. So 1 plus 5, this would be 6. And then the y is moved 3 units up. So 1 plus 3, you're going to put 4 in here. Does that make sense?
Yeah.
Okay. Oh, look at you. All right, just a few more. Okay, and whenever you're ready, we're doing page 95 to 96. Let me see if I have created an assignment for that already. Should have. What are you planning to do this weekend? Are you going anywhere? Anybody traveling? Are you leaving for somewhere?
We went to Oxnard.
Oxnard? Where's that? Fresno?
Somewhere northwest.
Oh, wow, that's interesting. I haven't been there.
Miss Arciaga,
Yes, dear.
how do we do slide 10?
Slide 10. Okay, let me.
Because it's not giving me a check. I don't know what to do.
Oh.
I just don't know how to check.
Okay, this one, you can write down a rule that looks like this. So for example, let me show the student version. Okay, you don't have to like save all the work, but for example, to match the, this is, oh, okay, so to match the original to this, I'll go 1, 2, 3. So I'll put x plus 3. X plus 3.
I did that.
And then, oh, there will be no like correct on that one because you will save just one of the answers. It won't save everything. Okay, and then comma. And then the y will be, it's faster if I write. Okay, that's going to be x plus 3. And then it's going to be y by how much? 1, 2, 3, and then 1 up. So it's going to be y plus 1. So that's only for the red one, right? Okay. And then later on, you're going to erase your answer to that one and try to describe the rule to get to the orange one. So eventually, it's going to be the orange one that will be saved. Okay? So that's why it just puts a dot. It doesn't show a correct mark because there are, what do you call this? There are 2 possible answers for the red one or for the orange one. Okay, for the orange, what's the rule for the orange? Starting from here, I go 1, 2, and then 1, 2, 3, 4 and a half. I counted 2 and 4 and a half. Is that right?
Yeah.
Yeah? So -2 and then 4 and a half going up. So if I counted right, that should be the transformation rule.
That's all we had to do.
Yep, that's all you had to do all 9. Okay, and then we're going to do the workbook. So if you're done, we'll go to the workbook next. Page 90 and 95.
No, it's 95, 96.
My bad, 95, 96. 95, 96.
I'm confused.
Okay, let's show some models right here.
Maybe a liar.
So for number 1, name the vector and write its component form. Okay, you're gonna count how long you're gonna move to the right or left, and then going up. So how much would that be?
That would be 4 to the right.
1, 2, 3, 4 to the right.
And then 5 up.
5 up. 1,
No.
2, 3,
No, 6
4,
up.
6 up. There you go. Okay, so that's how you will do the first set. Let's try to show number 4.
Wait, but it says you have to put the vector.
That's the vector component in component form. Okay. Now let's try number 4. Ignore the graph in number 4. Don't graph anymore. Okay. So skip this graph because they won't be able to fit all 4 of them in that little space. So we're just gonna write down the numbers or the coordinates. Okay. So for number 4, the original points are 1 and 2, and then B is 5 and 1, and then C is 5, 4. And then for each of these, we're going to apply the vector -4, 0. -4, 0. So what does that mean? For the x value, you're going to take away 4, and then for the y value, it's 0, so it's not moving. So it's technically like either y plus 0 or y minus 0, yeah? Okay, so let's write down a prime then. So the new number a prime will be how much? What is 1 minus 4?
-3.
-3. Comma. Oh, it stopped sharing. Hang on. Control K. Active panel.
It doesn't make any sense.
Oopsie. Delete that one. Then share. Okay. So now I have to go 1 space backwards. Okay, so as I was saying, you have the original points here. 1, 2, 5, 1, and 5, 4. So for number 4, you're doing -4, 0. So what this vector means is that you're subtracting 4 from the x, and you're not adding anything to the y. So technically, the y remains the same, right? Okay, so let's find the partner of a prime. 1, 2. So the original a, 1, 2 will now become what? So what is 1 and then -4? -3. And then y plus 0, this is the y, 2. If you add 0, it will remain 2. So that means if we were to graph it here, the new point will go to -3, 2. But just like what I said, we're going to skip the graphing portion, okay? And we're just going to do the coordinates, all right? Let's try again. What about the point B?
There's not enough room to write all that.
Maybe like, I would do like this. A prime is -3, 2, and then B prime, okay, let's do it like that. Prime is it tells you where the new point will go after performing the transformation, which is -4 comma 0. So the original point are these, and then when you do the prime, that means that's where they go after the translation. Okay, so B prime. Subtract 4 from 5.
1.
1. And then 1 plus 0, still 1. Okay, so then let's do C prime.
Just no room.
No, that's the last one. There's just 3 dots, right? Because it's a triangle. Okay. So 5 minus 4.
1.
And then 4 plus 0.
4.
It's just 4. Okay, so that's what you're going to do for each one of them. You will apply again the new vector, so you will get the coordinates of all the points. Okay. Then C prime and so on. All right, so try that one out. So we're missing Elena. Annie. Rylan. Okay, what happened to Rylan? When was it marked?
Football.
Oh, football. Yeah, together with Michael, right?
Yeah.
Okay, so where is athletics? Athletics. So 80, 80. Elena is. Oh, Elena also tennis, right?
Yeah.
Okay, so 80 athletic team. Camille also tennis, right? Okay. Thank you. Submit. No.
Yeah.
Period.
Excuse me.
Yes, dear.
A translation is like, a rule for the translation is like the last thing we did, right?
Mm-hmm.
Where it's like x plus and
Mm-hmm.
y plus.
X plus, y plus, or minus. You're right. If you were here yesterday and you haven't turned in your constructions, turn it in as soon as you can, okay? So you don't lose points.
Here's it. to put the little like B things.
Okay, let me do some quick help for number 8. For number 8, this is where you are going to write down the translation rule. So the quickest way is identify your old image, which is the solid one, because the dotted line image has prime. So from P, I count 1, 2, 3, 4 to the right, and then 1, 2, 3 up. So 4 right, 3 up. So when I write down the rule, I go x plus 4, comma, and then y plus 3. So that's the translation rule. If you want to write it in vector form, that's also possible. So you can write 4, comma, 3. There you go.
And so what?
This is for number 8. You can either leave it in
Oh, so that one's
the
just like
rule.
that one's like the one on 95.
Yeah, yeah. So you're going to count how many it went over and how many it went up. And then you're going to write it down as a rule or a vector.
So either one.
Either one, yeah. Okay, let me know if you don't have any questions about this first page, so I can switch to the next. There's a couple more questions on the other side. So let's do, okay, this one. Okay, so let me help you with number 12 before you can finish 10 and 11. In a video game, you move a spaceship 1 left, 4 up. That's your first transformation. And then what happens next is you move it 2 to the left again, and then that's it. You don't move, right? You stay. Okay, so what you need to do is combine these two. It's kind of like you're adding like terms. You're combining them and rewriting the composition. That's what we call it. It's a composition or a combination of several transformations. Okay, if you go 1 to the left and then you go 2 farther left, how many spaces you move in total? 3. So that's going to be 3 to the left. You move 4 up and you stay there, so it will just be 4 up. Okay, so that means as a general rule, okay, so what will be the rule for this one?
It would be x plus 3.
Plus or minus?
X minus 3.
X minus 3 plus u, and then?
Y plus 4.
Y plus 4. There you go. So that's the combination of the 2 types of transformation. All right.
So how do we do 10 and 11?
So 10 and 11 is when you plug in the x plus 6, so you add 6, right? And then you plug in the 5 into the y minus 3. Okay, so I think in middle school, our transformation lessons were more on, drawing, and then we gotta like slide pictures and images. So in high school, it was more on finding the coordinates, drawing their graphs on the Cartesian plane. Okay, and that's just one among the 4 for this chapter. So we're gonna discuss more next week. I was about to say tomorrow because I was out yesterday, so I feel like I have more energy.
So it would be x plus 10.
What's your x number? Yeah, so it's going to be 10.
And then y plus 2.
It's it's gonna be 2. Yeah, that's right. So put J prime, you put apostrophe. Yeah. You put apostrophe on the J, and then J prime, and then the answer. There you go. Yes,
I'm right or wrong?
0 minus plus 6 is 6, and then negative 5 minus 3, that's negative 8. Right? See?
I mean, because the thing is that there was this symbol, so I was like, oh, we gotta do the opposite.
Oh, no, you're right. Then I was wrong. Yeah, so you gotta do the opposite. You're right. I didn't see the prime. Okay.